foundations. Concrete used timber to create foundations. Aluminium. I found a Israeli designer that used aluminium with timber to create something that looks much better, but also it adds to structural rigidity. And finally, carbon fiber and glass fiber. It can coat timber and add about from 15 to 30% rigidity.
That would have been a quick instruction. Are you sure?
There's a pipe there, so half a kilo. Keep putting on the
Any questions? Tell us about the testing first.
Well, we didn't really test the bridge. The only thing we did do was put a book on it midway through the actual construction. That we didn't want to
So that was the first and only.
essentially.
That's brave. Well, there's another word for it.
It's confidence in the design.
Confidence. Yeah, I like that. Okay, yeah. How did you come up with that design? What was the idea behind it?
We researched and we found orange juice.
Yeah.
Tested it with this wood as well. We found that it's really, by using that time, it's really strong. So we now just went with
assembled like individual triangles and tested how strong that individual triangle was, and it was much stronger than using a longer piece of wood.
Okay.
So on that design. Also, as it divides the weight throughout the bridge. That's
Okay. Yeah, I mean, good. A truss structure like that is probably one of the better designs. It's quite a flexible bridge. Was that deliberate?
no.
yes, it is.
tried to divide it out so it all would fit over the length of 1.8. So we just fixed it at each piece is 6 inches or 15 centimetres, and that made up the distance quite well. Gave us a little bit left over to add to the bottom. That was the main reason, really.
The depth, you deliberately designed it to be quite deep. Yes.
Yeah, but it's all the same length all the way around.
Okay, so is that a good idea then? I mean, what would be the reasoning for having it as deep as possible?
Because time it takes to spread the depth, I think it facilitates the breaking easily.
Okay. Okay, really good. Thank you.
Good job.
It should be coming in a survey.
Good afternoon, guys. Kelvin.
Yanis.
Today we're going to talk about concrete.
So, presentation is based on concrete. So, what is a concrete? Concrete as a material mainly used in construction buildings. It is made out of gravel, sand, Portland cement, water, mixture. Construction project most probably without concrete. So, what they're considering this building, look around this building is all made of concrete. Referring to domestic buildings with this foundation, ground floor, all made of concrete. Also, concrete is very sustainable material. It can easily be recycled, reused in construction sites, building the land.
Concrete quite well. Concrete is very strong. It has great compression strength due to its resistance. Its tension strength isn't as well, mostly because of the weight. it limits the tension. It's very rigid. Holds things together. It can be reinforced by steel beams, while it can be reinforced with steel beams by adding it in the mixture while it dries.
So considering what my colleagues have said, let's have a greater view of what concrete is. Look around you, we started in a building, and all of you, I believe, will feel confident that you're secure and you're safe. And why do you feel that way? Because you're standing right under concrete. So basically, the foundation, the pillar, the columns are made of concrete, and that's due to the durable nature of concrete, due to the strength, due to the chemical component of concrete. This gives you that reassurance that you're safe. So what do we start with? Let's say concrete is synthetic and is mostly used in the construction industry, and is actually one of the most preferred choice by builders because it's wonderful. You can see this curve that's made of concrete, and that gives you the idea that concrete could be designed. So it could give you an architectural structure, it could also give you a reliable structure, it could give you a durable structure. So let's go further. Concrete is high in compression, tension, and strength, and also is stretch resistance. Concrete is also water resistance. When well mixed, that gives you a durable structure. Therefore, you show erosion, wind is not going to pull your building down. So let's talk about the buildings in general. Especially, this is where concrete are mostly found. Your foundation. For you to put a building up, you need to start by putting a column, right to the ground, and that is actually being covered by concrete. Now, why is that so? That is because concrete is made of chemical compositions, which are calcium oxide, silicon dioxide, aluminium oxide, iron oxide, water, and sulfate. All these are mixed with sand and water to give you this perfectly stable structure that you all are sitting on top. So, going further, concrete is sustainable. It lasts for a very long time. As you can use Greenwich University as an example, that building has lasted quite a while, and I can guarantee you it's not built of glass. It's built of concrete, and that is why the building stands very, very firm. So, concrete can also be recycled. So, crushing this concrete, reusing it, remixing it could give you another kind of concrete that could be well mixed to form another kind of building or put another structure up. So it's also a very good terminal conductor. It's of which a greater mass of concrete absorbs energy slowly and holds it on for a long period of time. So that also supports with the heating and the cooling of a property. So in conclusion, let's say, finally, looking for a noise-proof house, look for a concrete house. And why do I say that? I've used this statement, concrete is great for sound and noise insulation, and is great for, I've left it blank. The reason I've left it blank is because some of us live in a property, whereas your next door neighbor moves around, or they're doing private family stuff, and you all hear this noise. Now, in a concrete building, I can rest assure you, your property is soundproof. So why have I mentioned this? Because concrete is a very good material for soundproofing a property, and you can actually be rest assured that the cops will be called on you when you live in a concrete flat. And with these few points we've been able to put together, we do believe or hope we've been able to convince you, not confuse you, on our demonstration of concrete. Thank you. Furthermore, our idea of concrete gave us this inspiration of our bridge today. And with us today, we have a bridge which is a replicant of the Sea Wave Bridge, which is located in Florida, Miami. Now, this, as you can see, is nothing exactly like it, but our inspiration, our concept, our idea originated from there. Now, this is not a concrete building, obviously. This is a wooden structure, so we don't expect it to withstand the wind, the force load, the tension, such as the seaway bridge. So what we've done today is this: we've created a replicant of it. The seaway bridge is made of tension string, which is made of copper and steel, and we've replaced it with a string due to weight. We've also glued it rather than using bolt and screw, which is very similar to that of the seaway bridge. So from an idea from my colleague, we decided to add a support just to give it more support, rather than drilling into the floor and putting a column and a pillar made of steel, just to support and make sure that we have an idea of the seaway bridge, but we have created a flexible version of it. Now, our idea with this is the seaway bridge is what wind resistance, is also water resistance, is also shock absorbing, and that's just what we brought to you in a wooden version. Thank you.
He said he's trying to find package. No, I don't understand. Job. Yeah. He said you come back. So we just have to do it. Yeah, he needs to run. Yeah. No, don't go home. Stop the shit. That is up.
189.
So we just read them. Please remove it. Wow. One big.
We could destroy it.
What do we do? Do we continue?
Well, yeah, I would have tested it the other way up first.
Test it the other way up while it's still in one position or in one piece.
Let's leave it that way. Still didn't make it.
I think probably damage the middle.
What did it do? Was that 4 bags?
Upside down it was 4. Yeah, it's 2.
Thank you. We just have to do it, both of us. Just that's it.
It's still a 1. Kevin.
Oh, no, I don't think
Kelvin,
planning to-
questions?
But
Sorry, pardon me.
Actually, I'll ask you about Bridge Festival. You mentioned the design, but the cables that you've got in the real bridge, of course, were used in tension to support the centre of the bridge. How did you think that they were going to work with the type of bridge that you've got? Because clearly they weren't in tension. So
Yes, that's a very good question. From the initial design, I have a diagram of our initial design. We don't have it in the
yeah, don't worry.
What we assumed was the two tables apart, this acts as a support. This wouldn't move. Therefore, would hold the bridge stable. Therefore, when we put the load on it, this pulls the force, pulls it back while it holds on to the middle side of the bridge. That was the initial idea. But considering the original bridge is being built with concrete right through the water, so that holds it firm, and which is like an idea we're trying to imitate.
I was hoping that's what you would say, because effectively what you wanted to happen, you wanted these columns to be rigidly vertical and the cables to go in. So then the way you had it would have been the right way up, but because that's not how the testing setup is designed, it's not going to work. Had you been able to wedge those against something else, it would have worked.
How would you improve the design?
Yeah, to support it and to improve it, we would, I think we would change the total structure entirely. We're gonna, should I say, we're gonna increase the support up to an height of about 10 mils, further to the end of the bridge. Now that's to prevent it from being flexing. That's to prevent wiggling. And rather than use a tension string, I would use a wood. Now that's to hold it firmly as well and ensure that it's being held firmly. Upside down.
So maybe that might provide some ideas for.
Oh, yeah. That's how. Thank you very much.
Tell me about testing, did you?
Yes, we tested it. And we tested it actually with everyday materials such as a telephone, a textbook, a mobile phone, wallet, calculators. What we've just done is, as we built our bridge further, we were just dropping everything on it. Now, in the process of doing that, we tested our test load, we weighed it, and it gave us an average of about 0.9 kilograms. 0.9 kilograms. Now, we didn't further test it with more weight just to prevent creating damage to the actual structure. But in the process of testing it, we were convinced that our team efforts would be good.
But you tested it with the bottom of those columns wedged against something?
Wedged against something. Okay. Thank you very much.
It's a very good thing.
One man's gone to park his car, one's gone off on the phone. You could be on your own shortly.
You wouldn't be surprised. plastic bands. Stretch it and apply force to it, and it will break eventually, but it will stretch a lot. And then we've got the tougher plastic that it will take a lot of force for it to break, but it will also stretch out. We've got brittle plastic that will apply force to it and just snap. Durability. So plastic is a rather durable material that can withstand weather. Again, it depends on the type of plastic. Some plastics can be affected by sun. Others, when treated, can even withstand sun, rain, any other weather. We've got kind of an example of plastic that University of Gert produced. It is all made from bioplastics. So, just an example of how bioplastics can be used and recycled and how they can be useful in the future. And then sustainable quality. So we have a lot of plastic in our environment and everywhere around us. The thermoplastic, as we know, can be recycled and molded or reused. However, the thermostatic plastic is a bit more difficult to produce. We cannot remelt it, so the only thing we can do with it is reuse it afterwards. However, it is also made up of crude oil. So as we know, it's a finite resource. We just have to make sure we try to reduce the use of it. It also takes a very long time to decompose. So obviously if we bin it and leave it on the landfill, it's going to take millions of years to completely decompose.
The thing with plastic as well is the fibers its level takes a high amount of temperature for it to be melted down or broken down in that way. So you can see here that it takes a higher amount of temperature in comparison to other materials for plastic. So for instance, wood, we know that if we heat wood, for instance, that could easily burn, but plastic takes some time and the elements need to be broken. Thermoplastics are burned with temperatures ranging between 75 degrees Celsius to 105 degrees Celsius, which often melt, and whereby when it melts down, it releases high toxic fumes, which is quite hazardous. And thermosetting plastics also burn at a significantly higher temperature, which is ranging between 700 to 900 degrees Celsius in comparison to the first. You can see here that, as we know, plastic isn't a conducting material, whereby it doesn't really have any effect on electricity, whereby you can see that it's a material that is used to be able to insulate a room. So if we have plastic around the room, it's more heat insulated, more heat gets taken into it. You can see that we can use it in a construction environment whereby if you're creating a room, the walls can be plastic in order for it to insulate heat. And another thing is that's something good about plastic. Another thing about plastic, it tends to expand when heat comes into it. So for instance, if the sun was reflecting directly to plastic, it would then allow the plastic to expand, which is good because it reduces more heat. But this relates very to what about plastic taking time to break down.
Because of all the advantages of properties of plastic, you will find that plastic is commonly